Hello everyone, I am Dr. Jahnavi Chakrabarty, Assistant Professor, Department of Mathematics, Bardhaman College of Engineering. Today in this video, I am going to discuss the solution of algebraic and transcendental equation by Newton-Raphson method. Now let us look at this Newton-Raphson method. So here first we consider equation fx equal to 0 and we choose 2 points A and B in such a way function value at A and function value at B should be of opposite signs. So by intermediate value theorem we can say that there exists a root between A and B. Also we will assume that the initial approximation is given by x naught equal to A plus B by 2. Now let us look at how we can derive Newton-Raphson method using Taylor's series. So for this we will first consider let x1 is equal to x naught plus h be the exact root. So we know if this is the exact root, then the function value at x1 will be, therefore function value at x1 will be 0. Okay. So now what is this h actually? This is x naught point, this is x1 point, and this x1 is actually x naught plus h, this is h distance away. Okay. Now let us find expand f of x naught plus h using Taylor's series. So f of x naught plus h will be given by f of x naught plus h into f dash x naught plus h square by 2 factorial f double dash x naught plus and so on. So now what we will get, since f of x1 is 0 and f of x1 means f of x naught plus h, so this will also be 0. Since h is small, we neglect h square and higher power of h. So what we will get? We will get only f of x naught plus h f dash x naught is equal to 0. Okay. From here what we will get, h will be equal to minus f of x naught by f dash x naught. Therefore, a closer approximation to the root is given by x1 is equal to x naught minus f of x naught by f dash x naught. Okay. This is the first approximation. As x1 equal to x naught plus h, in place of h we replace it by minus f x naught by f dash x naught. So we get the first approximation. Similarly, we will get x2 is equal to x1 minus f of x1 by f dash x1. Then x3 will be equal to x2 minus f of x2 by f dash x2 and so on. So what will be the general formula for it? We will get xn plus 1 is equal to xn minus f of xn by f dash xn for n equal to 0, 1, 2, 3 and so on. And this is known as Newton-Raphson formula. Now let us solve some problems using this Newton-Raphson method. So this is the first question where we need to find the positive root of x4 minus x equal to 10 up to 3 decimal places by Newton-Raphson method. So we let f of x is equal to x4 minus x minus 10. Then what will be f dash x? F dash x will be 4x cube minus 1. Since here initial approximation is not given, so we need to find the initial approximation. So we need to choose 2 points A and B, and we need to find the function value at those points. So for that we need to make one table. So we have for x values what will be the function value. So 0, 1 and 2 we are taking values as 0, 1 and 2. So if x equal to 0, you will get fx as minus of 10. If x equal to 1, you will get f of x as minus 10. And if x equal to 2, you will get this is as 4. Okay. Since f of 1 is minus 10, that is negative, and f of 2 is equal to 4, that is positive. Okay. So by intermediate value theorem, we have that there exists a root between 1 and 2. Therefore, a root lies between 1 and 2. Okay. Therefore, what will be the initial approximation? Initial approximation is given by, this is given by x naught is equal to a plus b by 2. So here it will be 1 plus 2 by 2, that is 1.5, right? Now, by Newton-Raphson method, what we have? By Newton-Raphson method, we have xn plus 1 is equal to xn minus f of xn by f dash xn for n equal to 0, 1, 2, 3 and so on. Here this will be xn plus 1 and this is xn minus, what is f of xn here? Look at this, f of x is x4 minus x minus 10. So what will be f of xn? It will be xn 4 minus xn minus 10 by 4 xn 3 minus 1. Now let us take LCM here. So what you will get? 4 xn cube minus 1. So it will be 4 xn power 4 minus xn power 4 plus xn plus 10. Okay. So this one will be xn will be cancelled out. 3 xn power 4 plus 10 by 4 xn cube minus 1. So this side it is xn plus 1. Therefore, xn plus 1 is given by this. Okay. And here n equal to 0, 1, 2, 3. So now what will be the first approximation? So for getting the first approximation, we need to put n equal to 0. So you will get, therefore, x1 will be 3 x naught power 4 plus 10 by 4 x naught cube minus 1. Okay. So what was x naught? X naught is 1.5 power 4 plus 10, and this one 4 into 1.5 power 3 minus 1. So this will give you 2.015. Now similarly we can get the successive approximation x2, x3 and so on. So we have got x2 equal to 3x1 power 4 plus 10 by 4x1 cube minus 1, which is 1.8741. And x3, x4 we are getting 1.8559 and x4 is 1.8556. So look at x3 and x4. Up to 3 decimal places we are getting the same value. This is 1.855 and this is also 1.855. Since x3 is equal to x4 is equal to 1.855 up to 3 decimal places, therefore the required root is given by x is equal to 1.855. Now let us look at this another question where it is given transcendental equation, that is x e power x minus 2 equal to 0, and we need to use Newton-Raphson method to find the root of this equation. So first of all, let f of x is equal to x e power x minus 2. So what will be f dash x? F dash x will be x e power x plus e power x. Okay. Here also initial approximation is not given, so we need to find the initial approximation. So we need to choose 2 points A and B in such a way f of A and f of B should be of opposite sign. So for that we need to make one table. We need to take some x values for which we need to find the f of x values. So we have x f of x. So x values we will be taking as -1, 0 and 1. If it is -1, then f of x will be -2.76. If it is 0, then it will be -2, and if it is 1, then it will be 0.71. Okay. So for 0 it is negative and for 1 it is positive. Since f of 0 is -2, which is less than 0, and f of 1 is equal to 0.71, which is greater than 0. Therefore, our root lies between 0 and 1. So now what will be the initial approximation? Therefore, initial approximation is given by x naught is equal to 0 plus 1 by 2, that is 0.5. Therefore, by Newton-Raphson method, what we have? Newton-Raphson method, we have xn plus 1, xn minus f of xn by f dash xn. N is from 0, 1, 2 and so on. What is f of xn here? Xn e power xn minus 2. And what is f dash xn? It will be xn e power xn plus e power xn. Okay. Now let us take LCM. So what we will get? This will be xn e power xn plus e power xn, and this one will be xn square e power xn plus xn e power xn minus xn e power xn plus 2. So these two will be cancelled out. So what is left? Xn plus 1 is equal to xn square e power xn plus 2 by xn e power xn plus e power xn, and n equal to 0, 1, 2, 3 and so on. So from here only we will get the approximations. Okay. So what will be the first approximation? To get the first approximation, we need to put n equal to 0. So if you put n equal to 0, what you will get? X1. X1 is equal to x naught square e power x naught plus 2, x naught e power x naught plus e power x. Okay. So what is x naught? X naught is 0.5 whole square e power 0.5 plus 2, 0.5 e power 0.5 plus e power 0.5. This is equal to 0.9754. Similarly, if we put here n equal to 1, we will get the second approximation. Then we will get the third approximation, fourth approximation and so on. Now let us find second approximation. So we are getting the successive approximation. X2 is equal to 0.8634. Then we are putting that 8634 in place of x2 here. So we are getting x3, that is 0.8527. Then x4 also 0.8526. So we stopped at x4 because look at this x3 and x4, up to 3 decimal places these values are same, that is 0.852, this is also 0.852. Since x3 is equal to x4 is equal to 0.852 up to 3 decimal places, therefore the required root is x is equal to 0.852. This is the solution. Thank you.